Hello, and welcome back to another episode of Low Spec Labs. Before we get started, I would like to say thank you for the likes, thank you for the comments, and if you like this content and would like to receive more updates of it, go ahead and hit subscribe. Otherwise, let's get started. Last time we left off talking about managing Linux processes, how to stop them, how to start them, how to kill them. All very good and relevant stuff. Very fun. I hope you guys learned a lot along the way. I felt like it was a very informational chapter. Now, let's start chapter 11, where we talk about init systems. So that leaves a question: what is an init system? Well, to find that out, we first have to look at a little diagram, right? So I have a fun diagram I found on Google here that really explains the process for us. So the very first thing when we start up a Linux system is our BIOS. So your motherboard handles that. After your BIOS is your master boot record, which has to do with the way you format your hard drive. Then after that, you're going to have a bootloader like Lilo or Grub. Because we're using Red Hat based systems, our bootloader is Grub. After that, you have the actual Linux kernel, which boots up. And then the Linux kernel is going to start your init system, which is where we're actually talking about here. So what is an init system? It's basically a way to automatically start all the different services you're going to need to use a modern Linux system. That includes your networking stack, some, web servers, user management stuff, your desktop applications. It all really depends. The init system we're talking about today is called systemctl. And there's a long history behind systemctl. But on most modern Linux distros, it's the default init system. The reason that is because it works. And it works rather well. In fact, you might think it does a little too much for an init system, but that's a whole discussion for another day. In fact, if you go deep enough on some questionable Linux forums, there are arguments to be made for and against systemctl being a CIA psyop to control modern Linux infrastructure. Who knows? Let's go ahead and talk about systemctl and how it works. So systemctl is the baked-in init system of Red Hat-based Linux distros and Ubuntu and Debian and a bunch of other major distros. Why is that? Well, because systemctl just works. How does it work? So many questions. That's the problem with learning. You learn one thing and then you're like, wait, what about this other thing? And what about this other thing? And hold on, what you're saying is not making any sense here, bro. How about we start back at the beginning? And that's how you test your knowledge of something. And if the person teaching you can't confidently answer those questions, then does he really know what he's talking about? I would think not. Now, with that said, please listen in as I pretend like I know what I'm talking about. Let's get back to the subject matter at hand, which is systemd. So how does it work? Well, systemd uses what are called units. So inside of systemd, it starts different units. These units are the equivalent to services. What defines a unit? Well, there are unit files, which defines a unit. Something you're definitely going to want to know is the location of unit files. So to find them, we would go to etc systemd system. And then if we were to do an ls, you would see we have a bunch of different files. A couple of them are .targets, and then a couple of them are .wants, and a couple of them are .d. So .target files are basically defined states. .service files are, of course, services. .wants are basically unit files that are used to start other unit files. And then, of course, .d is, of course, other services or directory. And inside of that is more unit files, right? There are two other locations you can find unit files. The first is user lib systemd system, which is where they place your operating system's unit files or unit files created when you are installing an application. Do not modify these. There's etc systemd system, which is where you're going to place your custom unit files or edit unit files for different applications. You can modify these. And then last but not least is run systemd system, which is where automatic unit files are placed. Now that we know where our unit servers file is, let's look at an example. We're going to look at user lib systemd system vsftpd.service, and that's because vsftpt is a user installed FTP server, so the unit file is where the RPM based unit files are, which is user lib systemd system. When we open up that unit file, we'll see a very basic unit configuration, which is good. Basically, this tells the system what target we want to hit, and your systemctl targets are the services that should already be running for this unit file to run. Then we have the type of service itself, which shows us what type of service it is. And then we have exec start, which is basically the bash command to start it. So user sbin and vstb, which is our actual binary for the server. And then there's our config file, so let's look for those two. And then of course install, this is wanted by multi-user.target. So whenever we start multi-user.target, it's going to start this as well. Now let's go ahead and talk about unit files. So there are different types of unit files. Did you know that? I didn't, but I've educated myself, and now I know there are different types of unit files. So if we were to do a ls on user lib systemd system, like so, you'll see we have different unit files here. One of them is temp.mount. So what we can do is cat temp.mount. I know it says file directory. Let's see, mount, and look at that. So as we can see, this is a unit file, but it's a unit file that lets us mount a directory. So what that means is we can actually have a file automatically mount to a mounting point. This is useful because that means we can have a system spin up, wait for specific, system targets to be hit. And then once those system targets are hit, we can then mount file storage. And then after that, we can mount our services. There's lots of cool stuff you can do with unit files. So how do we know this unit files is being used for mounts? Well, there's two key things. The first is this portion of the unit file has mount right here. So that's one key thing to look out for. Another way is the description, where they tell us this is mounting temporary directory /temp. Another key thing to look out for is that the fact that the unit file itself is called temp.mount. So little tips there to help us figure out what type of unit file we're managing. Otherwise, let's get started. Let's talk about Linux sockets. What is a socket? A socket can be viewed as a virtual pipe that allows data, if data was water, to transfer from one process to another process. This data transfer can happen either within the Linux server itself using Unix domain or loopback sockets, or they can happen from one Linux server to another using network sockets, otherwise known as ports. All right, time to segue back into unit files. Why did we talk about sockets? Well, now that we know what a socket is, it makes talking about socket unit files a lot easier. See how we loop things around there, boys? At the end of the day, everything is connected to each other. In our last video, we talked about mount unit files, which are basically unit files that automatically mount file systems on our Linux server. Now we're going to talk about socket unit files, which are unit files that automatically open sockets or ports on our Linux servers. This is useful because maybe you want to spin up a web server, and in order to have that web server fully functional, you're going to want to make sure that port 80 is open. So this would be useful for resolving that scenario. With that said, how do we tell a unit file is a socket file? Well, there's a couple of ways. The first is that it'll end in .socket. So if we were to do an ls user lib system, and then a grep for socket, you'll see these are all the different files that end in socket. So all of these are socket unit files. Let's look at SSHD as an example for us to find another method to tell that a unit file is a socket file. So to do that, we would do nano, and then we go back to the end of this line. And then when we open up sshd.socket, we'll notice this is different from our other unit files. For instance, where previously it said service, it now says socket. You also notice that this is a much smaller unit files than the other one. And you also see that it's wanted by sockets.target. And one last thing before we start talking about socket unit files. Inside of socket unit files, there are going to be one key thing to remember, and that is the listen stream. The listen stream essentially defines the port that the socket unit file is going to listen on. By setting it to listen stream 22, we're setting it to TCP port 22, otherwise known as SSH. If we wanted to set a UDP port instead of a TCP port, we would do listen datagram. So that would be space listen datagram. I'm not actually going to change that because that would mess up my SSH config, but that's what you would enter. So listen stream for TCP, listen datagram for UDP. And remember, what is the difference between TCP and UDP? TCP is secure transmission. UDP is just letting it fly. They send that data loose and see what happens. So what is a systemctl target? Well, a systemctl target is a group of units. That brings us another question. What exactly is a unit? Well, a unit or unit file is a way to automatically mount services, file systems, ports, and other useful things on your Linux server. In that same way, a target is a group of units, and targets can be considered desired states. So you want your server to reach a desired state, you would create a target, and inside of that target, you would define a bunch of units you would want. Let's say you had a Linux server, and on that Linux server, you had sound that you wanted to process through a program. Well, in order to process sound, you would need a bunch of different sound applications and services. In order to get those applications and services installed, the suggested method would be to enable the sound.target, which is one of the targets we can enable on a Red Hat server. The cool thing about targets is that targets can be used to start other targets. So you can define a target file that starts other targets files and make that a high priority file. And then when your system starts, it'll start that file and everything else you need in sequence. So you can kind of build a tree of services you need running. Let's look at basic.target. So basically, this is a file that is one of the first targets that are started on your Linux system. And as you can see on basic.target, it basically says, man, that tells us where we can find information about this target. It tells us what starts before it, and it tells us what starts after it. That was confusing, right? Let's go over it one more time. So again, this is our basic.target. This portion is our wants. So wants means these are the different targets we want to start before we start basic.target. After means, again, we don't want to start basic.target until after these different targets have already run. Let's look at multi-user.target. So this is another target that starts other target. So this target requires basic.target to have already been started. Well, even though basic.target doesn't necessarily start any services, it is still a dependency of other services. Things like multi-user.target need basic.target to function. Something to remember is that target files also do not contain any information about unit files. So how do the unit files know what targets they're supposed to be in? Well, when you define a unit file, you decide which target it's going to be in. A visual example will explain the concept better. So in our right, we have systemctl.service. Inside of systemctl.service, we've defined a target. That target is sysinit.target. Sysinit.target has a bunch of services and mounts that it needs running for it to be considered successfully running. So until all these other services and mounts actually start up and sysinit successfully starts up, and temp.mount successfully starts up, this service is not going to be considered successfully started up. So in that way, if one of these were to fail and the service were to fail, we could figure out which one of these in the tree failed, and we could troubleshoot the root cause of the problem. There is one more thing you should know about systemctl before we go, and that's where the folder locations are. Do you remember those? I mentioned them a video or a couple minutes ago or a day ago or whenever the last time you watched this after I recut it up. Well, one of those folders from a video or whenever ago was etc systemd. This is where your target folders lives. When you enable a service, what happens under the hood is that a symbolic link is created in one of these target folders. So for instance, if we were to create a service and have it wanted by multi-user.target, a symbolic link in the multi-user.target folder would be created for that service. Let's go ahead and dive in. We last left off talking about systemctl unit files and how they can be used to automatically start services. Let's talk about systemctl itself, the commands, and how we can actually use it. This is the fun stuff. We just got through some theory. Hopefully it wasn't too boring for you. Let's dive deep. The command to manage systemd on Linux systems is systemctl. For instance, if we were to do a systemctl status, it gives us an output of different degraded service or basically broken services we have on this server right now. Let's walk through how we can use systemctl to enable a program we just installed and make it a service. First, we start by installing the application we want to turn into a service. So we do a dnf install -y vfstpd. It helps if you spell it right. It is vsftpd, and then it installs. We're done with that step. After we start the service, we then have to check the status. So when we run systemctl status, we can see the status is enabled and active. That's all and good, but if we were to shut down this server and reboot it, that service would not automatically start up. To make that service enabled, or to enable automatic restart, we would do systemctl enable. And what happened when we ran that systemctl enable command? Well, we read the output of the command. It says create a system link between systemd system multi-user.target.wants vstpd.service. So when we installed vstpd, right, it dropped a file called vstpd.service in the multi-user.target.wants folder. Then when we enabled vstpd, it created a system link or shortcut between this file and this file, and that folder is in systemd system, right? So basically link the installed service file to the systemd system location. Another thing you should understand is what exactly happens when you run that systemctl command, or rather the output of that status message. So let's break down this portion of that message for you. The first part of the command is loaded. Let's compare this versus the very first time we ran this command and we used loaded. You'll see, because we had started the service but not enabled it, the loaded field shows that the service is disabled. Now, if we were to scroll down and look at that loaded field, it shows us that the service is enabled. So what loaded shows you is the current status of a service, whether it's enabled or not. The next portion is the active service, which basically tells you whether or not the service is actually running. So if you see active, that means the service is currently tied to a process. Active has 3 warning states. Let's go through them. I've already explained active. Let's talk about the other 2. There is active excited, which means the service has successfully run once but is not currently active running. There is active waiting, which means the service is currently running but is waiting on another process or on an event from the system. The next state is actually the opposite of active, and that is inactive. And you'll see that if we were to stop the service. So if we were to do systemctl stop and then run status again, you'll see that the status of active has changed to inactive, dead. And then of course we can go ahead and start that service again. Other important fields include process ID, 753880 is our process ID of the process. And then the last but not least is duration, which shows how long the process has been running. Let's talk about systemctl again. So that would be systemctl status, and that is one of several systemctl status commands. There's a few other you have to know in order for you to have a firm understanding. So we'll dive into those. This is going to be a speed run. Basically, we're going to talk about the command and what it does. The first command we're learning is systemctl-t service. This command is used to list our service unit files. It lists all of them. As you can see, we have all the unit files on our system. The next command is systemctl list units-t service. This command is used to list actively enabled unit files. So you can see they're currently active, and you can see they're loaded and their active states. Our next command is systemctl list units-t service --all. And what that does is it lists inactive units as well as active units. So you can see we have both active and inactive units listed here. We then have systemctl --failed-t service. And what that does is it shows us currently failed services. Last of all, we have systemctl status-l vsftpd, or whatever service you want to throw at the end there. And what this does is it shows us even more detailed status information than regular systemctl status, stuff like cgroup slice. So very useful.